Welcome to my video of the British Mk.VIII autocontrols. The Mk.VIII was a late war autopilot for use in larger aircraft such as the Lancaster. In this video I will show you the main elements of this autopilot and I will demonstrate its various functions. Enjoy! Let me introduce you to the Mk.VIII autocontrols, which was a late war autopilot used by the British. It was used in heavy bombers like the Lancaster, Sterling, etc. towards the end of the war. In many ways it is a simplification of an earlier autopilot, the Mk.IV, and I'll introduce you to the main components. This unit here is the central gyro unit. It contains a gyro which can measure the roll of the aircraft, the pitch, and a little bit of the yaw movement as well. This control here is the pitch control with which you can actually control the pitch setting of the aircraft. So you can put it in a pitch up position, for example, if you want to gain altitude. This thing here is the main switch. If you put it to out, all the air is switched off. When you put it to spin, it's just the gyroscope running up, and when you want to switch on the autopilot, you put it towards in. Before I move to the other side, I'll just introduce this bit here. This is the master compass of the distance reading compass. It contains the magnetic compass and a gyro unit, so it is a gyro stabilized compass. So if I now turn my my model here, and we'll come to the front and we'll have some instruments. Just here we have a little air pressure instrument with two readings. One is the inlet air pressure, so how much air pressure you get from the air system. And here you have a little indication which indicates tail heavy and nose heavy, which helps to determine if the aircraft is probably trimmed when flying on autopilot. Here in front we have the indicator of the distance reading compass. We've got a switch which engages this compass and allows it to give a signal into the autopilot to steer left and right. So this wasn't a feature on earlier autopilots, but on this particular autopilot the actual magnetic compass, this instrument here, is used to keep this autopilot flying in the right direction. Here we have two switches which are of the distance reading compass. Here I have a little switch which switches my motors, my drive motors of the model, and you see two here. This little motor, it can actually drive the roll of the model, and this motor here, it drives here with a long screw. It drives a counterweight here which changes the pitch balance of the model and which allows it to pitch down and pitch up. So now we've come to the other side of this board and some other elements of the autopilot. There's two servos, one for the elevator and this one is for the ailerons. So this one controls the roll, this one controls the pitch of the autopilot. You will notice only two servos. There is no direct control of the yaw. So this movement, this turning movement, is not directly controlled by the autopilot. So how does it change the direction? Well, this is due to the aerodynamics of the aircraft. So if the aircraft pitches to the left, due to the aerodynamics, it will side slip and it will slowly start to turn as well. So basically the turn is controlled by the roll of the aircraft. So the rudder is not used at all in this model, and in the real aircraft either. Okay, So we have a clutch control here. If I engage that and put it down, it lifts these two clutches, and that means that these two wheels are running completely freely. So obviously when flying the autopilot, this clutch has to be engaged at all times, and it needs to lock into the correct position. Otherwise, click, the autopilot is not functioning properly. Here we have a relay box, and that forms the bridge between the distance reading compass here and the autopilot. So when the distance reading compass senses that it's a little bit to the left of the set point, it will operate some relays in here which sense a little air pressure, which blow on the gyroscope to precess it one way or another, and that will very slowly cause the model and the aircraft to turn back to the set point, or at least that's the theory. So I've now explained the various bits of this autopilot, so let's see if we can get it started up. So I've now switched on my electrical supply and my pneumatic supply, the air pressure. You can see now that this indicator here is pointing at 60 psi, so that's the supply pressure for the system. And by switching this switch to spin, I can now let the gyroscope in the autopilot run up. Likewise, I'm going to flick this switch to let the gyroscope in the DR compass unit run up, which is the noise you will hear in the background. Now, to make sure that it's aligned with the magnetic north, I'll put that switch, and you will see that this instrument is now starting to move. So if I stop it somewhere halfway, it goes into a slow setting, and now the compass is aligned with the magnetic north. So if I now turn the model, you will see that the compass indicator is following. So now the gyroscopes are run up, and I'm ready to start the model. First of all, I'm going to pull the switch to activate these motors, and now I'm going to put the autopilot on. And you will see it's waggling a bit as it's stabilizing itself. It is now trying to get the pitch to horizontal. It takes a little while for it to settle in. Switching on these British autopilots always was a bit of an adventure, and could cause quite wild swings of the aircraft while doing so. But now the autopilot has stabilized itself, and it's basically flying a more or less straight course. I'm now going to flick this switch, which engages this compass. Obviously, it will not show an enormous amount of movement because we're very near the set point. But now the model basically stays in this position. Okay, it may go up and down a little bit. The compass here will cause it to go left and right, maybe slightly around the set point. If you wait long enough, you will see that this starts to roll very, very slowly as it gets away from the set point. But we're talking very slow movements. They may take minutes rather than seconds. Let me show you what's happening on this side of the model. Here you have the two servos, which you see wiggle a little bit. So if I push the tail down, so pitch up, you will see that the servo is immediately reacting to that movement. Now this little wheel here is driving a little potentiometer which drives the motor here. You can probably just about see it move, and you can see there's a counterweight here, a pendulum, which is slowly shifted to bring the model back into this horizontal position. Likewise, if I push this roll frame to one side, watch here the roll servo, you will see that the roll servo is working in the opposite direction and will stabilize this movement. I'll also give it a bit of a turn so you can see the reaction to a yaw disturbance. So if I push it like that, you will see that the autopilot reacts by giving opposite roll and steering the aircraft back in the direction from where it originally came. So now the aircraft is basically stabilizing itself. And you can see that the set point here of the DR instrument is well, about 50 degrees from the current course. You see that I'll move the switch to the left, which engages the compass, and it will very, very slowly roll the frame to turn the aircraft towards this 30 degrees. The model, and you can now see that it's aligned itself to the set point. I can now actually put it in a pitch down position. There it goes. And now I'm starting to lose altitude. I will put it back to neutral. We're in stable flight again, and I'm now going to put a yaw disturbance in. You can see this is the gyroscope picking up the yaw movement and putting it in an opposite roll. Overshoots it a little bit. But eventually it returns back to almost the original setting. So I now give it a big shove the other way, and you can see it rolls. Goes a bit too fast. Rolls back. And settles back onto the set chord. So if you want to turn more than a few degrees, you can use the jink setting to speed things up a bit. So I'm putting it to jink. You can see it starts to roll, and now I make sure that about 15 degrees before the set point I put it back to compass, and it ends up near enough to the set point so that it can now slowly settle on the new set direction. Slowly, but I can also make the model move faster by putting it to jink. Now this puts a much higher input signal to the roll. You can see the model starts to roll, and as a result it starts to yaw as well. So as the model shoots over the set point, it goes in the other direction, and it ends up in this quite strong oscillation, which could be used as an evasive maneuver if they had an enemy fighter on their tail. So I'll try to make it quieten down a little bit. So jink could be used to evade enemy fighters.